Welcome back everyone to Data Science for Everyone. Today we're going to be looking at the US baby names data set. Let's get started. So the US Social Security Administration has this fantastic database of all the baby names starting in from like the 1800s all the way up to, the present. So what we're going to be doing today is actually playing along with that. Now there's a couple things that we're going to probably want to do. We're going to want to visualize some portion of the baby names. We want to determine maybe some rankings of the baby names. Also determine the popularity of each baby name by year. We'll analyze some trends such as like some vowels, consonants, lengths, and overall diversity of the names themselves. And we'll also maybe look at maybe some external sources if we have some time. So first off, let's go on and get in our basic imports. So we want to import pandas as PD. Let's also do maybe import numpy as NP, import seaborn as SNS, import matplotlib.py, plot as PLT, and then let's do matplotlib inline. Okay, now a couple things that we're probably going to kind of want to do is to take a look at what CSVs or text files that we actually have, and maybe even just kind of take a gander at what we actually have. So first off, let me go on and make a shell script here and do something like ls data names. I don't have, is my shell magic not working here? Let's see, let's try that. We should also be able to maybe do just this. All right, and so here we can actually see kind of all of the data sets that we have. This is from, and I can actually pull it up even over here. Data names, and you can see them all here. But I think it's easier just to kind of see everything on the screen. So we have everything from 1880 here all the way to 2020, and they all have this same format, this YOB, year of birth, and then it has the year on it with a .txt. Now the next thing that we probably are going to want to do, besides actually looking this up, is we want to also probably see what the format of these files are. And again, I'll show you guys how to do that just with some basic command lines so we don't have to look at anything. Let's do head, and I want to see the first 10 rows of data names, and I'll do something like year of birth 1880.txt. And we'll do maybe another one too here in a second just to double check. So what we see here is that these are definitely CSV files. Now they do not have a header on them, okay? Notice that there's nothing like name, sex, and number. Okay, so let's also maybe go through and do 2020. Okay, and we see the same thing here, okay? It's name, sex, and then the number that they have there. So we'll need to make sure, and again, this is just the number of births. So when we import these, we'll want to make sure and do something relatively straightforward with by giving them the name. So let's actually go through and just do one quick example just with this this year 2020. And let's do something like names 2020 is equal to pd.read CSV, and we have this, and then we want to actually have our names in here, and this would be name, gender or sex, and then births. Run this, and then we can do names 2020.head. And again, here we see that those are fine. Now, another thing that we may want to do is let's maybe group them by gender. And again, I'm just kind of showing you guys just a basic example of what we can do with this. And then we'll go on and I'll show you guys how to actually import them all. So we'll do something like names 2020 dot group by gender, And then we'll do what we want, births dot sum. All right, and so here again you can see that we have quite a few births of a male and female. Again, we have more males than we happen to have females in this instance. So again, this is just kind of showing us how we can kind of split up this data maybe by gender or in getting the total number of births. Let's go on now and actually get up the entire data set. So first off, let's do years here and do something like a range from 1880 to 2021. Now this goes up into, so let me actually show you guys, print list years. So you can see here now we actually get the whole thing. We get 1880 all the way to 2020, and we don't need that. Now, next thing is we actually want to, again, we're going to split up this data file by year. And then we also, one of the things that we're going to do is assemble the data into a single data frame. And then furthermore, we're going to add a year field, okay? Because we don't have a year field in any of the data that we have here. So we actually need to have that year field as well. And again, we can use this with pd.concat or pandas.concat. So let's go on and get that started. So first off, we need pieces. And then we also want in here columns, and then this will be name, gender, births. And then let's do something like for year in years, we want the path is equal to, did I have that saved in here? Yeah. And then here we want year of birth, d.txt, year. Now again, we could have done this a couple different ways. We could have used like an F string or anything else if we wanted to. And you know what? Maybe do I want to use this with an? Yeah, let's update this just a little bit. Instead of using these old ways, let's go on and we'll put in an, why does it keep doing that to me? An F string, so year.txt, and this is an F string. Okay, and that's grabbing in this year here. And then let's also do something like a frame is equal to a pd.read CSV here, and then we want in here our path, and then names is equal to columns. And then the next thing that we want is frame year is equal to year. And then we want all of the pieces. So pieces dot append frame. Okay, and so what this will do is this will give us in here a list of data frames. Okay, so we'll be able to congeal them all with a pd concat in just a second. So let me go on and run this. Oh, and what didn't it like? Let's go on down here. No such file directory as path. Oh, whoops. Sorry. So right there. Wasn't paying attention. All right, and pieces, because again, and append. There we go. All right, and so if we actually just, let me print out pieces here, you can see that actually it is, here's a data frame, here's another data frame, here's another data frame, and it'll go through if we actually print, and maybe I'll print out the length. The length of the pieces. Look, we have 141, so I have 141 years inside here. So then we can actually do our data set. So names is equal to pd.concat in here, the pieces. We're going to ignore index is equal to true. So head, now notice here that we actually have each of those, and we'll also maybe do names dot tail, and notice here you can see that we have in here 1880 to 2020. Now there are a couple things that aren't here. So again, let me kind of talk about this just a little bit. All right, so these frame objects are going to be row-wise by default when we create these. So again, that's what concat does. It actually glues each of them on kind of head to tail. And again, it's taking this and again expecting that these names are all the same. Secondly, we're going to have to pass in this ignore index is equal to true because we are definitely not interested in preserving the original number rows because again, then it'll just kind of repeat however many there are. And we have this really large file, so it'd be kind of messy to do that. The next thing to do, since we actually have all of this data, which is nice for us to kind of play with, is to go on and start maybe aggregating the data by year and by gender. And so then we can either do this a couple different ways, but let's go on by using the pivot table. Okay, so total births here is going to be names.pivot table, and we want births. Our index here is going to be year. And then columns in here is going to be gender. And then our aggregation function in here is going to be sum. So then we can look at something like total births dot tail. And we can look here, and again, you can see kind of the last couple of years with the total births for male and female. And again, let's maybe actually go on and make a nice plot of this as well, since we're here. So let's do something like total births dot plot, and let's give it a title of something like total births by gender and year. Oh, and I don't like that. There. Okay, and so now we can see that we definitely have this kind of nice kind of cycle going with these births and whatnot. But again, it always has this nice upward trend. Next, we're going to maybe insert some type of group for like prop or for something like the fraction of the babies, given their name relative to the total number of birds. Okay, so we'll have some proportion value, and we'll kind of play with it here a little bit. So let's add def add prop for proportion group, and we'll do something like a group here is we'll add prop is equal to group births divided by group. My fingers aren't working today. I have a new keyboard, and so I'm trying to get used to using it. Births, then sum. Okay, and then we want to return group. Oh, there's a forgot to put that. There we go. All right. So next thing that we want to do is actually do this. So names is equal to names dot group by. Here we want year. We want gender. Dot apply here. Add prop. Took it a second there. So names dot head. And here we can see our proportion in there. And so so let's kind of give you guys a bit of an example here. So some proportion of like let's just say 0.7 here would indicate that 7 out of every 100 babies were given a particular name. Okay, so that's going to be, so again, so in the 1880s, 7 in 100 kids, or this would be more like 8 in 100 kids, would have the name of Mary. So let's go on now and let's do a little bit of checking really quickly, okay, to make sure. So when we're doing this, we need to make sure that, again, this is a sanity check, okay, is to go through and verify that all of our proportion columns actually are going to add up to 1 based on the names available to us, okay, by their year. So we would do something like names dot group by year gender dot I don't like doing it that way. We'll do prop dot sum. Okay, and so here we can see 1, 1, 1, 1, 1, 1, and again our assumption is that everything in between is 1. Now that this is done, we're going to be able to subset a bunch of data to facilitate further analysis, maybe like grabbing the top 1,000 names from each year, okay, giving the gender year combination. And this is, again, going to be another group by operation, okay, so we're going heavily into our group by type analytics now, okay, so let's do something like def get top 1,000 by the group. Okay, so we'll have something, and I think maybe this time we can just do return group dot sort values by births, and then we'll have them ascending as false, and we'll grab just the first 1,000. Okay, and then let's go on and actually run this. So top 1,000 is equal to what? Oh, actually we need to group this, don't we? Grouped is names dot group by year gender. And the reason I'm doing this is we're going to come back through and we'll use this grouped by here in a second. We can actually we can add it on using the chaining method here to apply everything. But I have a feeling that we'll probably use this grouped by a couple more times, and I don't want to have to redo it over and over and over again. So let's do top 1,000 is equal to grouped dot apply, and we'll say get top 1,000. Top 1,000, we want to reset that index, because again it's going to be grabbing them all, and we'll do in place is equal to true, drop is equal to true. Okay, 1,000. Okay, and let's go on and top 1,000. Let's take a look. So again, now we see something like Mary all the way to apparently Ephraim and Willie, which is kind of nice. Again, you don't have very many birds in these because, again, this is the bottom portion of a list, the bottom portion of 1,000. This is the upper portion there. So again, this is kind of fun. This is our top 1,000 data set here. Is there anything else that we kind of want to look at? Now, yeah, let's go on and maybe start analyzing some baby name trends here in just a second. Let me go on and we'll segment this out really quickly to do this. So this here is analyze name trends, and again this is from 1880 to 2020. Okay, so we've already analyzed up the top 1,000 trends. Now what we may want to do is maybe let's split this in between boys and girls as well, and then we'll also look at maybe through some total births. So let's go on and split this up. So let's do male is equal to top 1,000 by top 1000, gender is equal to male. Oh, I don't know why it keeps doing that. Why? All right. And then we'll do female. Here is top 1000. Top 1000. Gender. New keyboard is driving me nuts right now. Is equal to female. And then let's see what else we're going to want in here. So with a simple time series, so we'll have something like Mary for each year, John's for each year. We'll be able to plot those out as long as that name's available in each year. But again, we're going to require a little bit more data munging than what it's going to be useful, because again, we need to form some sort of pivot table by the number of births each year. Okay, so let's go on and do something like a total births, and we want something like our top 1000 dot pivot table here, and we want this by births. Index is equal to our year. Columns is names. Aggregate function here is sum. And then we'll do a subset. Okay, so we'll let it finish running here, and then we'll double check maybe what names we wanna do. So I had a little bit of a hiccup there, and again, that's because I put in a name as a variable instead of name as a column name. So the next thing that we'll do is we want to kind of subset. Let's maybe look at total births info for now, and kind of see what we have here. And again, you can see that we have a ton of names here, and so let's maybe. We need to make sure and get some sort of names. And so let's do something like this is by name like this. Notice here, a couple things that we do notice, that there are a lot of nan values in here. Okay, because again, there's some names that are definitely not common, and we'll definitely have some that are not common, for example, later on. So maybe I want to make sure that I don't accidentally pick something that has a lot of missing values, and I kind of want you guys to kind of understand how we could go about kind of adding these up. So we can do something like is null here, and notice we have these trues and falses, and then we can do something like sum. And then we, maybe we want to do what? How many do we have column-wise? How many rows? Rows. Here we have 140, so we can do something like divided by 141. And we'll multiply by 100. If we want the percentage, okay, that's the percentage that is null, okay, and so then maybe we want to also do something like let's do print here. Oh, and it's not going to do all of it. Let's see, what is the best way that we actually do this? Let's say, do we have any that are equal to 100? cut this and do what? So let's actually double check on something else. Instead, we don't actually want this. We want it closer to 0. So we want kind of like a complete data set. At least for now, I'm going to put this in here and we'll in brackets, and we'll do something like total births dot is null dot sum, and run this, and notice here now we actually see all of these that are pure non-missing values, and then we should be able to do something like we can sample 4. Okay, so we have Dean, Ellen, Jay, and Joel. So that's what we're actually going to do about our plotting. We'll plot out these names. So again, maybe they're not the most famous names or anything else, but at least we can create up a subset based on them. So total births here is going to be Dean, Ellen, Jay, and Joel. And then we'll do something like subset dot plot. Subplots is true. Fig size in here, we'll do something like 10 by 10. And then we'll do grid false. Title is equal to number of births per year. Oh, and let me actually let me zoom out a little bit so we can actually see things. And I want to put that there. All right, so we can see here that at least these names, they all kind of had some kind of their heydays already, at least for Dean, Ellen, Jay, but then Joel seems to be a relatively recent name. So you can see all of these slightly different trends and all of these, and this is kind of fun to really see. Now, another thing that we're probably going to want to do is maybe look at the diversity of names. So how different are names? So maybe, I don't know, maybe there's a lot more Marys and Joes and Bobs in the 1960s than there were today in the 2020s. Okay, so let's go on in and start doing that. Let's measure the diversity out. So do we think it's going to increase or decrease is actually kind of the big thing here. So measuring name diversity. Okay. So again, are there going to be maybe is there going to be a decrease in there? Is going to be there an increase? Now, a couple things that we can kind of say. Okay, so one thing for a decrease is, again, there's maybe fewer parents. Okay, choosing common names for their children. And again, this is just a hypothesis. Okay, now we can explore this and confirm this with the data. Okay, so one measure of this proportion of births by the top 1,000 most popular names, okay, which we've already kind of aggregated again by year and by their gender. So let's go on and create up a table, and we'll just call this tab for table here. And we'll do something like top 1,000 dot pivot table here, and we want this by the proportion, okay? Index is year, columns is going to be gender, and our ag function here is going to be sum. So tab.plot here, title will be something like sum of top 1,000 prop by year and gender. Okay. Then what else are we wanting in here? Y ticks is equal to mp dot lens space, 0 to 1.2 by 13, and then we want our X ticks in here to be, what did we have? Range from 1880 to 2020, no, 2030 by 10s. Yeah, I think that'll do. And let me also put this here. And you know what? Let's also give it a little bit of size difference. Fig size is 10 by 10. There we go. So now we can see here that there is definitely this widening and this higher diversification of names. It appears that there's definitely an increase in our name diversity or a decrease in the total proportion in the top 1,000. Another interesting metric that we can kind of do is maybe talk about the number of distinct names. Okay, and taken, for example, we can look at this as the popularity of a name by highest to lowest or lowest to highest. Maybe we can look at the top 50% of those births. So this number is going to be a little bit more tricky to compute, considering that we need to do this by boys' names and by girls' names individually. Do we want to do this by what? Let's see what we want to do. Let's do it this way. Okay, so I'll call this DFB for data frame boys. Boys by boys by year is equal to, let's just do 2020. Oh, whoops. Boy. Didn't do it by boy, right? Oh, male. Sorry. Male and male. So DFB dot head. Okay, so again, we get something like Liam, Noah, Oliver, Elijah, and William. Now, sorting the proportion in descending order. Okay, so we want to know how many of the most popular names in each reach at least 50%. Okay, and we can also write out this. We can do this in a for loop, and we can do this using the cumulative sum. Okay, so let's go on and do that. So, all right, so let's do something like, prop cumulative sum is equal to DFB dot sort values by prop. Ascending is false, and then we want this by prop dot cumulative sum. So let's go in and look at maybe the top 10. So prop cumulative sum through 10. So okay, so we need to actually do search sorted in here, because we actually want to find, for example, how many values are at least at that 50% mark. So let's scroll up a little bit, and we'll do prop cumulative sum dot values dot search sorted by 0.5. All right, and we have 162. Okay, that are above that 0.5 mark. Okay, so we maybe want to do something. Again, here we see this 172. Now we may want to see about if we add a 1 to this, for example. We'll see that it gives us a result something like a. So let me just do something like a plus plus 1. Okay. Notice it just gives us this singular added on value. Okay. And again, that's because again this is just singular values. All right, because it just comes up to just a number for us. So we've seen this and it works quite well. We may want to go about this and seeing how we can do this maybe by doing the quantile, and we want to do this by everyone, by all the genders. Okay, so we can actually apply this operation quite well. Now let's give us let's see, how many are we going to want here? The reason that we also would want to add in this is because things are indexed by 0, okay, because some of those values may have 0 in them, so we want to make sure that there are no missing values. So let's go on and do something like def get quantile count in here. And we'll do this by group. Q is equal to 0.5. Group is equal to group dot sort values, and you know we can go on and just grab you. And you know what? This will be group, and we want to maybe let's move this down and do return group cumulative group dot no, not dot, group prop cumulative sum, and then we'll do value sort in here, and this will be Q. So that we can kind of get everything in there. And again, this +1 is going to be taking care of any 0 values that we may come across. And again, we can always change up that quantile if we want to deal with the quantiles in a little bit. And this is supposed to be an F in there. So let's go on and actually create up a diversity data set then. Diversity is equal to top 1000 dot group by, here we want year, gender, dot apply, and we want this to get quantile count. Diversity is equal to diversity dot unstack gender. And then we can go through and let's just take a real quick look at diversity dot head. And we see here that we're definitely, there's not a lot of change in there. So let's actually go on and let's plot this out. Okay, so we can really see how the diversity looks. Because again, here you can see there's definitely probably not a lot of diversity in there in the beginning. And again, maybe that was just about records at the time. Number of popular names in top 50%. Fig size is 10 by 10. Well, and I don't want that. Okay, so we can definitely see that overall female names have definitely had more diversity over the years, and they actually seem to have taken off quite rapidly. Everyone did almost in the 80s. So that's kind of nice to see. Again, girl names have always been more diverse than boy names. And again, we also see that over time there's always been more and more diversity as we've gone. We've had a couple dips here and there. Furthermore, this is one thing that we that this doesn't take into account is alternate spellings of names. Okay, so for example, Mark with a K, Mark with a C, those types of things. So we may want to kind of deal with that type of potential mismatches in the name changes and everything else. And then we also can say, like, for example, here's this In 2007, there was like the last letter revolution type thing. And we'll leave that maybe for the next video. If you guys like this, please comment, subscribe, and hit that like button. And I will see you guys next time. Bye-bye.